Hello and welcome back. A key part of working with data is also publishing our data, and this is what we're going to talk about now. Let's recall the data life cycle. We have two separate steps where we need to think about how to make data preserved for the future. First of all, the preservation step. Here we want to future-proof our data so that we can access them even in 10 years' time. That includes, for example, converting our data into open file formats. We also need to think about how we can preserve the analysis environment, for example, in a virtual machine, like all the software that we need to access the files and repeat the analysis in 10 years' time. Try to think ahead and say, okay, if everything is now very different, like 6-7 years into the future, how can I retrieve those data and analyze them? We also want to share data. So which part, if any, can be shared with the community and what is of value with the community? When do we want to share it? Right when we acquire the data or after our project is completed? As we've said before, there is an organizational side and a technical side. On the technical side, we need to make sure how we actually process and store the data. But from the organizational side, we need to think about who does what. Typically, funding agency mandates us to store the data for more than 10 years, and this is what most systems do. But maybe if we want to think a bit ahead and say, okay, how can we actually do this longer term? What happens after those 10 years? How can we make a commitment to long-term storage? What happens when the 10 years have passed? So first of all, we need to future-proof our data. So it's not just publishing the data as it is for our own reuse, but we also want to revisit maybe the same data once our software environment has changed or a vendor has made an update, but that's incompatible with the previous version. What happens in 10 years? But also identify which data should be published for the community. Everything, parts of your data. Maybe we have also legal or contractual obligations. We have personal information or non-disclosure agreements or sensitive data that can only be shared after maybe 5 or 6 years. What should be shared? The raw data, the process data, both? How do we deal with analysis code and software environments? Once we've taken these steps, we also need to identify a suitable repository for publishing. Here are some questions how we can identify such a repository. So we aim for long-term storage, so let's think a bit longer than the 10 years. What can be stored in such a repository and how long is the storage guaranteed? Who operates this? Is it a non-commercial repository? Are there any fees or hidden costs that we need to take into account? How about access right management or embargo policies? Will the data have a persistent identifier? What kind of license requirements do we have? Does the repository impose a license on us, or are we free to choose the license for our data? Will the metadata describing the data always be public, even if the records aren't? Are the metadata machine readable, for example, in a JSON format? And then do we choose a specific or a domain-specific or a generic portal for publishing our data? When we publish our data, we always need to think about a license. So there are lots of licenses and we need to choose some of them. Here are some questions that we need to ask ourselves. So do we give up all rights on the data so it can be used even commercially by a company in a few years and sell a product based on our data? Or do we require attribution or non-commercial? Or do we allow the modification of our data? Quite often we want to choose a Creative Commons license. Here CC0 is public domain, we just give up all our rights. Everybody can do what they want with our data. And then there are different versions of the Creative Commons. For example, users are free to use and distribute, but they have to credit our work. Or the share alike, the SA qualifier says that if you use the data and amend it, you have to give it the same license. And you can also forbid commercial use or no derivative works, like no adaptations of our original work. It's important to note that once we've specified a license, it cannot be revoked. Once applied, they cannot be changed. So we need to make this change early and consciously. There are, of course, other licenses. There's the GPL, also often called copyleft. There you make everything available, and any modification also needs to apply the same license. Then there are different versions to this, like the Mozilla license is a weaker version of this, or the Apache is a bit more permissive. You keep copyright notices, but the modifications can be published under a different license. MIT license is often used as a very permissive license. You keep the copyright notices with the data or with the metadata, but modifications can also be published under a different license and so on. There is also the unlicensed, there is no condition whatsoever. So you need to be clear of how you want to publish your data and maybe also your analysis code. When you think about publishing data or code, you need to think about copyright. And here there's a big divide on the, shall we say, US-centric approach and the European-based approach. The way copyright is handled in those legal systems, and there are probably others in different countries that have a very different concept too, is fundamentally different. And let's focus on the US and European-based legal system here for now to just give you an idea what to think about. And it's something you probably haven't thought about before. And depending if you come from the US or if you come from the EU and work in different systems, you have a fundamentally different approach to what you feel copyright should be or is. So in the US-based approach, copyright can be transferred. For example, when you're an author, you give your copyright to the publisher. You also have the concept of fair use, so that you can use copyrighted material in some circumstances without having to require permission of the copyright holder. Of course, there are lots of requirements on this, but this concept exists. In the European-based approach, however, copyright cannot be transferred whatsoever. It's a personal right, it's attached to your person. If you, for example, write a text, you cannot give up your copyright. But what you can do is you can grant rights to others, and you can even grant exclusive rights to others, for example, to your publisher. The European-based approach doesn't know of any fair use. So that means you always need permission to use material, either because the data has a license that you have to comply to, or because you can ask the people and get their personal agreement. In particular aspect of this that, for example, images cannot be cited. Note that a copyright holder also holds a copyright for derivative works. So if you just change the color in, for example, a sketch or in an image, it doesn't prevent copyright infringement. So let's come back to sharing and publishing data. So there is Re3 data, and that's essentially a search catalog for other repositories. It's not a repository where you can publish data yourself, but it's like a search engine for repositories. It helps us discover material and data across different repositories. This can be a great tool to find repositories that are useful for your specific community, if there exists some already. If you work on georeference data or Earth system research, and Pangea is probably a repository for you. It guarantees storage for 10 years, then subject to availability. The data do get a unique DOI, and you have an embargo period for up to 2 years. It's a moderated repository. That means that if you want to submit data, it will be viewed by an expert gremium, and the size of the stored data is up to negotiation, up to 100 gigabytes at the moment, but of course that can be more. You need to contact the moderators. Data can be deleted without notice if you violate some laws or good morals. There's a gremium within Pangea who decides that, and it requires you to use the following licenses: metadata as public domain, and all data as typically Creative Commons BY by default, but you can choose other licenses. Materials Cloud is focused on computation material science. It doesn't really allow experimental work, only if you have a theoretical component to it. For example, if you work with a materials cloud partner to improve or disprove computational results. It's also a moderated repository, provides a permanent identifier, and guarantees storage for at least 10 years after submission. It's operated by the Swiss National Computing Center, irrespectively of the fund of the materials cloud, so there is no guaranteed availability or service level agreement, but it's operated by the national infrastructure, so there's some safety there. The Creative Commons license is preferred, but there is a long list of licenses to choose from. And they also provide research data management plan templates for various funding agencies. Again, the data can be removed if it violates some laws or is deemed inappropriate by the moderators hosted at EPFL. Zenodo is a generic or general repository for all science. This is not specifically tied to a particular community. It's operated by CERN, and it's guaranteed that the lifetime of the data is there as long as CERN exists. So they give like a 10-year guarantee, but they say they will operate it for as long as CERN exists, and CERN as an international organization has any prospect to last for many more decades. Zenodo doesn't impose any restrictions or format, file access or the license. You can also have closed, restricted or embargoed content that is intended for later open publication, and there's a total file size limit at the moment for 50 gigabytes. Of course, you can ask them if you have really large data, and you must choose a license for public data, but you're free to choose a license you like. Content, again, not within scope of Zenodo, will be removed. All data files are versioned, so there are also nightly backups and multiple copies, so in case of data failure in one compute center, there are others to pick up from. So sharing data or code or artifacts is part of our best practice wherever possible. It allows us to build a community and establish more work and prior work. For example, for data intensive applications, machine learning, AI, this is really crucial. It also makes science more reproducible because you can share the data and say, here's the analysis code that I use with this data to get those results. There are a number of repositories available that we can use to publish our data. So there are generic and general ones like Zenodo and specialized ones for a given community. Most repositories are centered around the 10 years requirement mandated by the funding agencies. Do read the small print for the actual commitment that they do. As an exercise, in your project, determine which data could be shared in your research project. Then identify a suitable license under which you might want to share your data, and then determine which repository fits your needs best. Having done all of this, share some data.